Hi, I'm Kelly Morrison. I'm here today to talk about the Java 8 date time API. Since there's a lot of sessions going on, I want to be mindful of people's time. Here's a quick overview of what I'm going to talk about. So look it over. If there's anything here that you're interested in, please stay. If not, there are plenty of other good sessions. You won't hurt my feelings if you leave for a better one. Just leave a couple of dollars at the door for my therapy session, for my abandonment issues. So basically, the Java date time API is one of the most misunderstood ones I've seen in all the years I've been a software developer. I've seen some horrendous code. So I wanted to take an hour and just kind of sort through some of it. So I thought I'd start off with an introduction, some of a rogues gallery, some of the worst things I've seen. Then I'll take you through a brief history of time, kind of show you some of the highlights. The history of times and dates, that's fascinating. You could spend an entire day talking about it. I mean, it's got some weird stuff in there. But I'm going to hit a couple of the highlights. We'll talk about UTC, which is Coordinated Universal Time. I'm going to talk about the ISO 8601 standard. Then I've got a surprise time standard that I'm going to sneak in there, you might like. Then I'm going to talk about the early Java date time API. The original one that came out with the first version of Java and stayed in through 7. And it's still there now, for backwards compatibility purposes. It's a terrible toolkit. And quickly, a new one came along called Jota Time, which was a plugin replacement. And then finally in Java 8, they fixed it properly with the date time API. So then we're going to move into a coding session. I'm going to walk you through some of the major pieces, show you how they work, how to use them. We'll look at a few examples. I'll give you a few hints about unit testing when you have dates and times. Then I want to briefly mention 310. I'm just going to basically give you an URL for it. And then we'll just have time for resources, session questions. I'll give you some links to LinkedIn and a link to the slides. So everybody decided to stay, yay. Okay, basically to set this off, my name is Kelly Morrison. I'm a Georgia native. I've lived here my whole life. I've got a doctorate in computer engineering from Auburn University, War Eagle, and I have a bachelor's degree in mathematics from the University of Georgia, so go Dogs. And I've been a software consultant for the past 6 or 7 years. And before that, I worked at a lot of stand-up, startup corporations and other companies. These are some of the ones I've worked at here. You can see there are a lot of Atlanta ones on there, like CNN, Home Depot, Turner. Right now, I'm working at Edward Jones financial company, so it's been an interesting one. Even worked at Marshall Space Flight Center. Back before the International Space Station was the ISS, it was called Space Station Freedom. And I actually worked on a contract to do some software work for that. So I still have my little lanyard. It still has a space shuttle on it, so I love that. So it's been an interesting career. And right now I'm working at Doherty Business Solutions. They're headquartered in St. Louis, but they have offices around the country and a few overseas, like in Poland. So if you're interested in coming on board and working with us, come over, I'll give you a card. Okay, you're probably wondering why I'm talking about Java date time. Java 8 came out a long time ago. So the API has been out there a good while. But there's a reason. I've worked at company after company with a lot of different programmers, and I have seen some terrible date time code. I mean, it's just the worst API that I've seen people deal with. Over and over and over. It's the one that causes people the most grief. So I'm going to 3 quick examples of bad use of it. I'm going to show you, and then we'll get into the rest of the presentation. The first one, this one blew my mind. This is at a company about 7 or 8 years ago. Actually, come think of it, it's more like about 12 now. Time passes. Anyway, we had a guy on the team, he knew regular expressions really well, but he didn't know anything about dates and didn't care to learn. So he had a piece of code one day where he had to take out the hours, minutes, and seconds for the current date and time. And here's how he went about it. You can see up here, he has date, current date equals new date. That basically gives you the current date. So far, so good. And all you really have to do after that is to create a formatter to format that date properly. This guy didn't know anything about it, didn't want to. There was too many classes there, he wouldn't be bothered with it. So what he did was he would turn it into a string. If you print it out, this is what it looks like as a string. And then he wrote a regular expression to grep out the hours, minutes, and seconds. Yeah. So he wrote a regular expression, he compiled it, he tried to match it against the string version of that date. And if he found it, he took that group out. and said, here's the time. That was an interesting PR review. Yeah. I just looked at it, it was like the SpongeBob, like, yeah. Anyway, that was a fun day. That was one of the most horrendous ones I've seen. It still wasn't the worst code I saw on that project. We had another guy on the team that knew Java, but he didn't know anything about databases. So he figured out how to pull data out of the database. And instead of like doing searches on the database, he pulled all the records in the memory and then searched through them using Java. So it worked great for a while, and then all of a sudden it started slowing down, and then all of a sudden it just bogged completely down. And I went in and looked at it and started to fly up to Minneapolis to chew that guy out. But instead, we just fixed it. Yeah. Second example, formatting. This guy decided to do it himself. Again, like, he took the current date, and he wanted to do the same thing, like, hours, minutes, seconds. And again, like, he didn't know about simple date formatter, didn't know there was building code to do this simply. So what he did was he actually picked out the pieces, like hours, minutes, and seconds, and then he used a string format to put it together. And this works. It's not that bad, but it's not the best solution. It's kind of clunky when there are better methods. And then the third one is the one that ruined my new year. The day the unit test died. I was working on a project with a team, and we were doing scheduling appointments for like a company. And we had some code in there where they had to check to see if it was summertime yet, because when summer came, you had a couple of interns that would join, so you have more manpower to throw at things. So we were running this code, everything worked great. And then January 1st came around. Everything stopped working. We couldn't deploy the software because the unit tests were failing. Unit tests were failing on everybody's developer machines. Like, people hadn't even touched the code. People had been out for a week, came back and found their unit tests weren't working. It was just like sunspots had hit. Because like it was on different environments, different machines, different branches of code. Nobody knew what the problem was until we went and looked at the unit test. What they were doing in the unit test, they were trying to figure out the first day of summer. So they were creating a new date, and they were setting them off to June. And now you see a 5 there, and think June's the 6th month. This is one of the problems with the original date API. Month started with 0. So January was 0, February was 1. So again, you're already like starting off on a bad foot. But he set it for June 1st, and then he used the current year, 2012. So it worked great until like summer came along. Then it was like, okay, the date's after it, so everything's great. Everything worked great. New Year's came and passed, and January 1st, he's looking at the date, and it's January, so you think it's not summer yet. But it was comparing it to the previous year. So even though like he'd set a hard-coded year for the first day of summer, he was still using a dynamic one, which meant the unit tests worked day after day after day until they didn't. So that was interesting, and that led to a little session about how to properly use dates and times when you're doing unit tests. So that's 3 of the ugliest ones I've seen. There have been quite a few more, and then there were some that were really interesting. None of the original classes, like date and calendar and simple date formatter, none of those were thread safe. So if you like started a format in one thread and then tried to use them in another one, they'd conflict and you get really screwed up dates. So there's just a lot of problems with it. So here's where you might ask yourself, how do we get to a mess like this? How do people that are bright in so many ways, how to do regular expressions and how to write services, and then they just can't figure out how to do dates? Well, you can go back, it's really confusing. And if you look at it with fresh eyes, you start looking at all the terms that are used. These are some of the terms you find in the Java date and time APIs. And there's a lot of weird ones in there, like chrono unit, all set, date, time, epoch, ISO. If you don't know anything about times, you're wondering, why is this so complicated? Why can't I just say, give me the time, give me the date, give me the year? That's all I need. But instead, we have stuff like this. So it's kind of like, a hard thing for people to get through their head, and it leads to a bad use of the API. And how do we get to that state? Well, if you go back and look at a history of time, and I'll try to be a little more entertaining in this minutes and a little less annoying, but there's a couple of key points. And again, you could talk about time for an entire day. It's a fascinating subject. But I just want to hit a few of the weirdest points that kind of explain some of the weird decisions and the way we keep time today. For example, why are there 24 hours in a day? Why are there 60 minutes in an hour? Why are there 60 seconds a minute? Who decided that? Those are just weird numbers. I've always wondered about it. So I went back and figured it out. The story starts back in Egypt in 1500 BC. This is when Egypt started getting really serious about trying to track dates and times. And it actually had kind of a concept of it for like a long time before, at least 1,000 years. But it was just until then, I guess they were tired of working on pyramids and sphinxes, and they decided, okay, let's do something about time tracking. So they came out with two inventions. One was a sundial, and one was a water clock. The sundial obviously was used for keeping track of time during the day. And the idea is that as the sun moves across the sky, its shadow kind of moves around. So what they did was they put a stick on a stone, and the stick would throw a shadow, and they would track how the shadow moved around. And they split the time into 12 equal divisions. You can see there was lines going straight out on both sides. That's dawn and then sunset. And they split the time between dawn and sunset into 12 equal parts. And then for telling time at night, there's no sun, and the moon doesn't throw enough light to do a sundial. So they came up with something called a water clock. And that's the original one up in the top. This is a modern reproduction of it at the bottom. But a water clock was basically a pot filled with water. It had a very slow drain in it. And it would drain through the night. They'd fill it up at sunset. Then, as it drained down, they had markings inside it to tell them what time it was. And again, they used 12 different markings inside the water clock. So they had a concept of 12 divisions during the day and 12 at night, which leads to 24 hours. Yes, there's one of our numbers right there. Now, you're probably wondering, why did they pick 12? I mean, why not 10? We all have 10 fingers. Unless you're a polydactyl or had a really bad time in shop class, you have 10 fingers. So why not just count to 10? Why don't we have 10 hours in the day? 10 hours in the daytime, 10 hours at night, 20 altogether. Well, we count fingers. We count 1, 2, 3, 4, 5, 6. The Egyptians actually counted a little differently. And this was actually pretty smart, and I never even thought about it until somebody mentioned this to me. There's evidence that they actually counted to 12 on each hand. And the way they would do that, there are 3 joints on each of your fingers. 4 fingers, so that leads to 12. And then you can use your thumb as a placeholder. 1, 2, 3, 4, 5, 6. So you can count to 12 on one hand. So 12 was very natural for them. And there were other reasons. They had a constellation of 12 stars that were important to them. But basically 12 was very important to them. So they tended to break things into 12s. And we can still see that today. If you look at the Earth, it's split into 24 time zones. Each one's basically an hour. So this dates all the way back to some poor guy saying, hey, I can count to 12 on my hand. So next stop is in Babylon around 1000 AD. And the Babylonians were also interesting. They didn't use base 10, they didn't use base 12, they used base 60. Which is weird. I have no idea why they did that. But if you think about it, 60 is an interesting number. If you want to divide it equally, there's a lot of numbers that go into it. You can divide 60 by 1, 2, 3, 4, 5, 6, 10, 12, 15. That's a lot of ways to split it up evenly. So it was a nice round number, split easily. So it was important to them. And anyway, this guy named Abu Rayhan al-Biruni, and I apologize if I massacred that name. I grew up in South Georgia. Everybody was named Bob, Billy Bob, or some kind of variant of that. But anyway, he had an idea of splitting an hour down into smaller parts. And he split it into minutes, seconds, thirds, and fourths. And I'd always wondered why they call it seconds. It's because it was the second in a series. And these actually came from Latin terms. And the terms are over here. Oops. Stop, Jake. Yeah. Okay. There's pars minuta prima. And again, we don't speak Latin in my South Georgian town, so I'm sorry if I'm butchering the language. It means first small part. Pars, of course, means part. Minuta means small, and prima means first. And then for second part, pars minuta secunda, second small part. And there are similar terms for thirds and fourths. So kind of wondering why they didn't just stick with prima. We could have hours, primas, seconds, and thirds, but instead they picked the minute part. So, and again, they were using base 60. So every time they broke one of these down, they broke it by 60ths. So they broke an hour into 60 minutes. They broke a minute into 60 seconds. They broke a second into 60 thirds, and they broke a third into 60 fourths. So it's getting down pretty small, because a fourth is 1/3600th of a second. And then you square that to get what part of an hour it is. It's pretty big number. I have no idea why they wanted time like that anyway. This was in 1000 AD. They didn't have digital computers. They were measuring things in nanoseconds, so it was an interesting way they did this. Okay, but anyway, if you're wondering where we got seconds and minutes from, that's from them. Oh, by the way, this isn't this guy's real picture. This was from a Soviet stamp in 1973. They didn't have any existing pictures of him, so they just hallucinated one, kind of like ChatGPT. So if you think about it, this is a Russian version of a ChatGPT hallucination circa 1973. One or two more stops. We stopped in 1675 in Greenwich, England. Has anybody ever been there? Wow, okay. I'm obviously not cultured. This is on my bucket list. I've always wanted to go there. This is where the Royal Observatory was. And this is actually where the prime meridian for the Earth is. If you want to start at some point on the Earth and go around, this is the beginning point, or the ending point, or both. So this is like, the prime one. And there are actually more than one prime meridian. Paris actually had their own. They had a meridian and went through Paris, France. Did anybody see the Da Vinci Code or read the book? Okay. If you remember the Rose Line, that was their prime meridian. And there were others, but when you have a lot of places around the world all saying like, hey, I'm the starting point, something's got to give. And the Brits won this battle. So we came out with Greenwich Mean Time, which means the line running through Greenwich is the starting point for measuring around the Earth. And if you look at it, these are the time zones. You see numbers along the bottom here, like +1, +2, -1, -0. The 0 one is where Greenwich is. And the meridian goes halfway through the zone. So if you pick like the zone with a 0 in it, find the middle of it and run it up, that's where Greenwich is. That's why they call it mean. Mean, of course, means average. So it's the average time in that zone. Then in 1955, we got the atomic cesium clock. Up until then, they tried to track time to match the sun. And the sun's not consistent. Actually, the Earth's not consistent. You think that the Earth rotates at a constant velocity, like every day it covers the same amount of time, but it doesn't. The Earth kind of wobbles a little bit. And the reason for that is it's not a perfect circle. It's kind of misshapen, it's lumpy in places, it's kind of scooped in. So it kind of like wobbles a little bit. Then you have the sun pulling on it, you have the moon pulling on it, so it's a three-body problem, like the Netflix show. Then you have things like volcanoes, you have magma inside the Earth's crust sloshing around. The oceans are sloshing around, but it's all this stuff happening. It makes the Earth kind of wobble a little bit. So sometimes it's a little faster, sometimes it's a little slower. So they have to keep tracking the time, like add a second here, take a second away there. And they call those leap seconds, and eventually like it adds up. You have like a full day for a leap year. But in 1955, they decided this is kind of clumsy. Let's just track it using cesium. So they built a clock, and they used the atomic active element cesium, and they used the number of vibrations it does to establish a time code. I don't know why they picked cesium. There was probably a good physics reason for it. In my head, it kind of went, they built the clock, they were trying to figure out what to plug into, and it's like, well, the military's got the plutonium and the uranium, the computer guys have the silicon, phosphorus don't work, and then some guy's like, hey, I got some cesium on my shelf in the office, let's plug that in. Hey, it worked. But that's my little head version of it. I'm sure like the real version's a little more scientific and a little more boring. But anyway, this became like the new standard. They would check this. There are actually several different atomic clocks, and they kind of take the average of them to get the current time. Next, 1963. This is when I was like still in diapers. So I was born in December of '62. What started happening? They started recognizing there was a need to have a common time format around the world. And all these different countries had their own time ways. Like some had a Gregorian calendar, some used daylight saving time, some didn't. So they got together and came up with a standard called Coordinated Universal Time. The abbreviation is UTC. And you're probably wondering, why isn't it called CUT? That's because this is an international standard, and they wanted it to be the same letters in as many languages as possible. So for most of the world, that would be UTC. The United States is CUT. We're in the minority, so we didn't get a vote there. But anyway, UTC basically is kind of similar to Greenwich. They both are headquartered there. The Greenwich, like Meridian and UTC, you can think of them as almost the same. There are a few little differences, but for most intents and purposes, they're the same thing. So, like I said, UTC tries to track the atomic clock closely, but the Earth wobbles a little bit, so they have to keep adjusting it. And there are different ways of handling it. If you look at how Java does it, when they add a leap second, they don't just like dump it at the end of the day. They kind of like distribute it throughout the afternoon. It's interesting. Or at least that's what they say they do in the documentation. Under the hood, who knows? And something else interesting, since you can't predict leap seconds, there's no way to get the exact difference between a UCT time now and a UC time in the future, because we don't know what the time will be in the future. You think like add X seconds and there you are. But since the Earth slows down and speeds up and we have to keep adding or subtracting leap seconds, we don't know. So that means it's impossible to get the exact difference between a UTC date now and one in the future. So if you're getting to something that needs like very specific times, like keep that in mind. Then we have something called an epoch, or epoch. I've heard it both ways. An epoch is basically a fixed point in time that computers use to count. And the most famous one is called the Unix epoch, which starts January 1st, 1970. And what happens is they started a counter, and every second they would add 1 to it. So the Unix epoch counts the number of seconds since 1970. And that actually led to a small problem that's popping up. There's a year 2038 problem. Does anybody here remember Y2K? Okay, this is its little baby sister. Yep. The reason is the number, they've got a field that's only a certain width. And eventually, if you keep adding 1 to it, it's going to overflow. And that overflow is going to happen in 2038. Luckily, it won't be anywhere near as bad as Y2K, because most Unix machines already are on 64-bit, which is good for 292 billion years. I don't think I'll be around then, so it's probably somebody else's problem. But there might be some existing systems here and there that still use really old hardware. Yes?
I remember a problem, I think around 2004,
yeah.
Because the 32 representation started using this moving bit, and a lot of the code assumed it was, they were using the signage instead of
right.
32-bit integer. So it caused a little bit of, I had a problem with it. I didn't write it good, I was using some code that could problem with it, so I had to quickly download and get a patch version of it. Before I hit that, modern version of that.
And there's actually more than one. Not everybody uses the Unix epoch. Windows uses a different start date. There's a whole bunch of them. So there could potentially be more than one of these year 2038 issues popping up. But anyway, just remember what a Unix epoch is. It's the number of seconds since 1970. Then we get to ISO 8601. And if you've ever worked on a project where you had to do anything doing dates and times, you're probably familiar with this. It's basically an international standard. It says how we describe dates and times in time zones so that we can interchange information around the world. And there really isn't a single format. You'd think it'd be something like YYYY-MM-DD, whatever. It's more like a programming language for describing dates and times. There's a zillion different ones. Let me show you some examples. These are all ISO 8601 standard times and dates. And you can see they're all over the place. You can have only a date. You can have a date and a time separated by the letter T. You can have a time zone offset, the third line. You can see the plus 0200. That means you're 2 time zones away from Greenwich time. There's also called Zulu time. That came from an old naval thing. Zulu time and GMT are the same thing. They both mean the meridian that runs through Greenwich, England. You can do fractional seconds. You can actually even specify periods, durations, 3 years, 6 months, whatever. You can put ranges from April 10th to April 20th in 2024. It's just all over the place. So if you say you're going to parse an ISO 8601, you all should always ask which one, because there's a lot of them. You can define your own. So, it's constrained a bit. There's you can't just put anything in there. But, it's like I said, it's like a programming language that describes how to format a date and time. And this is the way I looked at it when I first saw that standard. I was like, oh, come on, this is really complicated. Okay, remember we said universal coordinated time? or UTC. It turns out when they said universal, they didn't really mean universal. What they really meant was terrestrial. For example, if you're talking about the moon, like it doesn't work for that. The moon's not split up into 24 time zones. There's no offsets. That's a completely different thing. The universal coordinated time only works for Earth. It's a terrestrial time. And the reason I'm bringing this up is because there's a brand new one coming out called Lunar Coordinated Time, or LTC. And this just was announced about a week or two ago. There was a director from the White House. He issued a task force for people to get together and describe a time zone, well, basically a way to describe times and dates on the moon. And they do want to link it to UTC, so that's going to be fun. But, they're just now getting the committee together. If any of you are interested, join up, have some fun there. And if you want to know more about it, here was the news story about it. This is a QR link that'll actually take you to the White House announcement. I think it's about a 3-page document that describes it. So even though we think we've got enough with UTC, there's still more coming. So probably in Java 35 or something. Okay, that's enough history. Let's go back and actually look at something practical, which is what we're here for. Early Java. Anybody worked on Java before version 8? Wow, okay, I'm not the only person here, thank God. Okay, if you remember the early Java versions before 8, they had a couple classes like date, calendar, simple format. There were a lot of problems with them. For example, none of these were thread safe, so you could get into threading issues with it, especially simple date format. You always had to be careful about that one. They also didn't correspond to the domain very well. For example, date doesn't say anything about time, doesn't say anything about time zones. It didn't care, it didn't know about them. It was just a date. Calendar, was set up for a pluggable architecture, but never really worked that great. And it was just a mess. So some people got together and fixed some of the problems. Like I said, some of the problems were no time zones. You saw earlier today where we looked at the example where they had June was starting with 5 because it started with a 0 index. They used the local system time in too many places under the hood, so you got weird results. Then there was a SQL date class for SQL, and it didn't really match up with the date in Java very well. There were issues between the two of those. And it's not really a date, it's more of an instant. It never really captured a date, time, and time zone. It actually counted the number of seconds since the epoch. So it was just a mess. It was confusing. Get day, return the day of the week instead of the day of the month or whatever. And there were some weird holes in it. You could actually specify January 32nd and it would take that as February 1st. So, hey, it's a feature, not a bug. So to clean it up, some people got together and came up with a framework called Joe to Time. And this was a lot cleaner. For one thing, it was thread safe, so you didn't have to worry about that. They actually work with a lot of different calendar systems, and they made ISO 8601 the default. It had a better API. It was fluent. All the classes were immutable, so you couldn't tinker with them. Got better performance. The original daytime API had some issues, or sometimes it was bogged down for no good reason. This one had better performance overall. It was less confusing, and it actually became the de facto standard daytime for Java earlier in 8. There's still some people that use old versions for compatibility reasons. So if you have to use an older version of Java, plug this in. Don't use the date that's actually in it. And the designer of Joe to Time was a guy named Stephen Colborn. And even though Joe to Time was a lot better, he still, after implementing this library, thought, there's still some design flaws in it. It works, but it's still not as good as it could be. It could have been handled a little bit better. So he got a chance to do that. He actually worked on the Java 8 date and time API. They didn't just take Joe to Time and slap it into Java. They looked at Joe to Time, saw what it did well, saw what it didn't, and then they wrote a new Joe to API for Java dates and times. So it's inspired by it. It's got a better design, but it's not the same thing. And they actually put the APIs in java.time, that package. In the original version of Java, dates and times are so unimportant, they just jammed them in utils. So it didn't even have its own package. It does now. Talking about explode here. Okay, let's look at some of the classes that are in the new Java 8 date and time API. There's one called local date, and you can imagine what that does. It's actually like the time that you're at. For example, we're here in Georgia, so it shows us the local date in Georgia. And I've got some code examples on the left here, and here's the output on the right. It's really easy. If you look there, you can actually take localdate.now, and it takes like the date on the machine you're running it on. So like if I'm running on my laptop here in Georgia, it's going to be the local date here in Georgia. So like I did this code yesterday, so 4/11. You can add stuff to it. You can do localdate.now and then add a number of months. Like you can add 1 month to it. So up here you can see if today is the April 11th, and 1 month from now will be May 11th. You can add days to it. You can add months. You can even like chain these together, because it's immutable. Every time like you call one of these classes, it creates a new instance that's immutable. So you can just keep chaining it together, modifying it. It's always going to be like an immutable class. You can also like subtract values. Like you can take today and subtract today to get yesterday. You can take today, take a year off, find out what it was a year ago today. And then there are actually some that are interesting. For example, there's an epoch, min and max, that are built in. You can see what those are. You can see Unix is 1970, January 1st. The min date and the max date are pretty big. Like I said, I'll be long gone before these roll over. And then you can actually create ones. The bicentennial line there, you can do local date of, and you can plug in like a year, month, and a day, and it'll put that together. So it's pretty simple. Local date is just the local time. Doesn't have any time concept of like time zones or where you're at. It's just like what time you're at, where you're at. It also handles leap years properly. For example, up here, I took February 28th in 2023 and added a day to it. And you can see it became March 1st. But this year is a leap year. So if you start with February 28th in 2024 and add a day, you can see it goes over to February 29th. So this is an advantage over the original, and this handles leap years properly. Then there's local time. And just like local date, local time shows you the time where it's at right now. If you do local time.now, it's like looking at your watch. It's like that's what time it is now. And there's some predefined ones. There's noon and midnight. See, noon is 12 o'clock, midnight 00. And then the min time and max time are pretty much what you expect. The min time is midnight, and the max time is like just a nanosecond before midnight. And again, you can like chain these together. You can add minutes, seconds. You can subtract them. And then you can actually like create a local time. Like on the bottom, you can see local time of April 28th. Excuse me, local time of like 4 o'clock, 20 minutes after. So those are pretty simple to use. They're immutable. They got a clean, fluent API. Not too bad. Then there's local date time. This one basically smashes the two together. It's a date and a time. So, and again, it's pretty much what you expect. Local date time.now gives you the current date time. Again, you can like add things, like you can add subtract days, weeks, months, seconds, minutes, whatever. And if you look at how it prints it out, you'll see it looks a little interesting. This is an ISO 8601 format. Sorry. And if you look at the way it works, basically you have a year, month, date, and there's the letter T. T separates the date from the time. And then you have a time format, like 2 hours, 54 minutes, 33 seconds. I think that's nanoseconds. And there's more you can add to it, but local date time, it only cares about where you're at right now. So it doesn't have to worry about like you adding a zone or offset or anything like that. Okay, now let's start talking about where we are in the world. This is where zone date time comes in. A zone date time is basically a date, a time zone, and a zone ID. And what that means is the date and the time are obvious. Like date might be like February 1st, 2024. Time might be like 3:05 p.m. The time zone and the time zone ID are interesting. And I can show you what those are down here. This is what a time zone looks like, America and New York. And there's a zone offset. If you remember the map of time zones, they have like plus and minus numbers showing the hours around the world. You're probably wondering why they have both of these, a time zone and an offset. And there's a good reason for that. If you go back to our map, thought I copied it over here. If you go back to our map, we have zone offsets. That's the numbers here. For example, our prime meridian is here at 0. And if you look at the eastern United States, we're over here at 4 or 5, depending on what part of the year we're at. So like right now, we're on offset of 5. Okay, so this is our zone offset. The problem is, though, the United States is up there and has daylight savings time. These countries down here in South America may not. So just knowing the offset isn't enough to figure out the time. You gotta know the offset plus what country you're in. And that's why we have an offset and a zone ID. The offset tells us basically how many hours we are away from Greenwich. And the zone ID tells us which one of these countries we're using to figure out the offset. Because it may modify it. If we're in daylight savings time, we add 1, we subtract 1. That was one of the confusing things to me when I first started this. I was wondering why they had a zone offset and a zone ID. Let's catch back up to where we were. Right. And there's actually a database under the hood that keep updating. So it consults that and figures out. But again, just knowing the offset's not enough. Knowing we're 4 hours away from Greenwich isn't enough. We got to know if we're in the U.S. and if we are, we do daylight savings time. So we might change that offset. So, what's that? Yes. Yeah, most of us are only concerned about the hour. Right now, for example, it's 2:07 in Savannah, Georgia. It's 2:07 here. It's 2:07 on the state line at Columbus. And then cross over the state line, it's 1:07 over in Auburn, Alabama. But if you think about it, the sun's slowly moving along. It's not really the same time here as it is all the way over in Savannah, 250 miles away. Savannah is a little bit later in the day than we are. So that's why the offset has hours and seconds and minutes. So it's 4 hours, and then it provides time to actually locate something within it. But for most of us, the hour's good enough. If you're working on something missile tracking, you need something really precise, you'd probably want the fractional part. And you can also format the dates properly. There's something called a daytime formatter, and you can specify a pattern. For example, years, months, dates, hours, minutes, seconds, and then Z for a time zone. And it'll format it. You just take the time and call format with a formatter. And there are a lot of predefined ones. There's a huge number of them. I've got a few here. There's the ISO 8601 zone date time, week date, local date time. So you can see what they look like. Yeah. So there's a lot of those built in. You don't have to go through and figure it out yourself. You can just call one of the predefined ones. Okay, now let's talk about instance. This gets interesting. An instant, remember we talked about Unix epoch and we said it counted a number of seconds since 1970. An instant is kind of like the Java version of that, except it's a little different. It doesn't count seconds since 1970, it counts milliseconds. So an instant is basically 1,000 times what the Unix time is. So, and you can actually create one here. You can say I've created 2 times, a New York time and an LA time. And you can say I gave it, for the hours, I gave it 5 o'clock for New York, and I gave it 2 o'clock for Los Angeles, since we're 3 time zones apart. And then I used the zone IDs, and the one for 5:30s in New York, one for 2:30s in Los Angeles. And then if you print them out, you can see it actually prints the times properly. It's 2:30 Pacific, it's 5:30 Eastern. But if you print them as an instant, there's a 2 instant, you can see they're basically the same thing. That's because the instance, the number of milliseconds since 1970, doesn't matter where in the world you are, it's the same number. So even though the local time looks different, the instants are the same. What's that? No, this is correct. Yeah, an instant, if you look at UTC time, this is what the time would be over in Greenwich. You can see it's the same as the instant. So you can almost think of the instant as the time in UTC. And then you can actually convert from one to another. For example, if you knew New York time, you want to see what time it is in LA, they have this overly complicated method name. It's called with zone same instant, and then it takes a zone ID. And what that means is that you want to use a different time zone, but the same instant, and format it. So starting with like a New York time, I want to format it for Los Angeles, but for the same instant. And when I do that, you can see it looks like this. So again, like, if it's this time, this is the time it would be there. It's 2:30 Pacific, which is what it would look like here. So we took a New York time, which is at 5:30 Eastern. We told we want the same instant, but in Los Angeles, and it basically printed out here, it's 2:30 Pacific. So that's the magic method. If you want to convert from one time zone to another, that's the method you use. And you pretty much know most of what you need to know about the datetime API now. Zone datetime, use the time zone like that to tell it what country within the time zone. And then you can use that magic method to convert from one to another. But there's a few more I want to show you so you get your money's worth. There's something called offset datetime. And remember we said that a zone datetime is several different things. It has a date, a time. It has a zone offset, which tells you which one of those blocks around the country of the world you're in. And it has a zone ID, which tells you which country in that offset. Offset date time doesn't have a zone ID, so it can't handle daylight savings times. Remember, a zone ID is used to look up a country within a time offset. If you don't have one, it doesn't know what country to use, so I can't tell if it has any weird quirks like daylight savings time. So offset date time is just a little interesting. It can't handle things like daylight savings time. You're probably wondering why you want to use this. There really aren't a lot of good reasons for it. If you look at documentation, I think they use it where you're more concerned about the time, not where it's at. They mentioned logging, but it all sounds kind of iffy to me. And honestly, I would say probably don't use this. On the other hand, there are some good classes called periods and durations. And these are used to tell the differences between two times. Period is for longer ones, like years apart, months apart, days apart. And the other one is for smaller periods, like in minutes, seconds, that kind of thing. So you can see in the code here, I've actually taken the current time, and then I added 3 months, 15 days, and 12 hours to it. And then you can figure out how far they are apart by creating what we call a period. And there's just one method, period between, you give it 2 dates. So if you take that period and print it out, you can see you get this weird little P3M150. The P stands for period, and it means 3 months. 3 months, 115 days. Yeah, a D looked like an O here, and I was thinking, where did 150 come from? Yeah, so the period is 3 months, 15 days, which is what we added up there. So we added 3 months and 15 days. It didn't care about the hours. On the other hand, duration, same thing, duration between, and give it 2 times. And you print it out, and you see it's 255 and then 6 hours. So periods for longer periods of time. How long before my Netflix subscription expires. Durations for shorter periods of time, like how fast did that wide receiver run the 50-yard dash. So, but you can use them interchangeably. It's just if you use period for long periods of time, you get huge numbers. Here it's 2,556 hours. Yeah, I did the math on it. If you take a duration, there are methods like today's part to hours part, and it basically breaks out the number of days, number of hours, that kind of thing. You can format it different ways. Yeah, I think there's a formatter for that. Usually you don't look at the formatted version like that, the default one. You usually just pick out the parts you're interested in. Okay. But that's 2 useful ones to know, duration and period. Period, again, is for long periods of time, like weeks, months, that kind of thing, or even years. Durations for smaller time periods. So that's basically a quick summary. Forget all the huge amounts of documentation there. Forget all the different things. Like all you really need for most of your work is zone date time. Again, it has a date, time, it has a zone offset, which tells you where you are around the world. And it has a zone ID to tell you what country you're in, so you can look up any weird rules. And it actually handles it under the hood for you. Like you don't have to tell it to calculate daylight savings time, it does it for you. So there's also date formatter. You can use it for format to your preferred format. It's got a lot of the ISO standards in there, so you can print out like things that conform to the ISO standard. But you can also create your own custom formats if you'd like to see it a different way. And then finally, the one real method you need that always confuses people is the with zone same instant with a zone ID. And that basically means you have like a date and time in one time zone, and you want to figure out what that same time is in a different zone. So that's the way you convert it. So for example, if it's 9:03 in Atlanta, it might be 6:03 in San Francisco. Yes? There's actually a method you can call in it that'll list all the strings. And it's a huge number and they're not sorted. So yeah, I don't know why. You can also go to the documentation and it's got it like listed there. And they actually add and create new ones here and there, and I think they take some off, like after the recent services, I think they took Kiev out. So I don't know why they took it out. That probably broke some code here and there, but it's a dynamic thing. And then the underlying rules change. For example, right now in the United States, there's talk about doing away with daylight savings time, which means that for the zone IDs, you'll have to update the tables under the hood to deal with that. No, very important ones. They're always tweaking it. They make changes to it each one, but it's usually like small utilities or convenience methods. But I don't think there's any major ones. Java 8 was the big one. And actually, now you bring that up, let me skip ahead a few slides. There's a website called 310. Has anybody ever heard of that? Okay. Well, here's what the web page looks like. 310, you can almost think about as an incubator for new Java time features. And in fact, they were working on it here, became JSR 310, and they actually moved it in, became Java 8. So they sometimes put stuff here and move it into Java. It's kind of like a incubator or a place to think about things. They also have a backport. So if you want some of the Java 8 methods, you can backport it to Java 7 using their library. So that's an interesting one to look at. And like it says here, there are videos and articles. And it actually has a link to the OpenJDK part where they maintain the code. So if you want an inside look at how they do Java dates and times, that's pretty good. Let me do one or two more things and then we'll quit. We'll talk about unit test. If you remember earlier, at the very beginning of the sketch, I mentioned that we had the unit test that broke because they hard-coded a date and a time. Well, if you're like me, you probably have all your code that says new zone date time or a new date. And if you have it dynamically generating dates all through your code, it's hard to test. So what you want to do is isolate it so you can mock it out. And there's a couple ways you can do it. For example, you can write a function that gets the time and nothing else, and you can mock out that function in your unit test. Or if you want to get fancy, you could actually write a time factory that has a get zone date time or a get now method. And that way you can inject it in your code, and if you want to unit test, you can do a mock version to inject in your code. So it gets the mock time from that. And I'll show you one example of that. This is a typical piece of code. You can see I got a method called rtext is due today. And you can see the first line in it gets the current time, zone date time and now. And it checks to see if the month is April and if the day of the month is 15. And if so, it says yes, taxes are due today. Any other day it says no. So the problem with that is you can only run that unit test on April 15th to get it due true. Every other day would return false. So what you really want to do is be able to test both cases. So what you can do is you can break it up like this. You can see what I did was I took the line that gets the zone date time and broke that into a separate method. And I made it package protected. So it's obvious that it's used here, but you really don't want to use it elsewhere. It's an internal function. And then down here in my real method, I call zone date time now, calls that one to get the time. So it looks like it made it a little more complicated, but it makes it easier to test, because here's the way that works. What you can do is you can actually like override that method. For example, I can create an instance of that class and override that one method to return whatever date and time I want. So I've got one where it returns false, and I've got one where it returns true. So this way, instead of having it just dynamically create a time inside your class, you can actually tell it what time to use. Yeah. If you ever read Michael Feather's book, Working Effectively with Legacy Code, this is what they call a seam. That's a great book, by the way. So that's one way to do it. You just break out a method and override it. And the other one is you create a factory and inject it. So then you can inject whatever mock you want. And that's basically all I wanted to say. We already talked about 310. Here's a couple of links for you. First QR code here is a link to my GitHub repo. If you go there right now, it's an empty directory. What I usually do is do a presentation, see if there's any interesting comments, corrections, additions. I make tweaks and then post them a day or two later. So the slides will be up sometime this weekend. If you want to look at my LinkedIn, there's a QR code over there in the bottom. And if you want to get in touch with me, there's my work email address and my personal. And again, I work for Dougherty Business Solutions, consulting company. It's got branches in St. Louis, Atlanta, Poland, around the country. I think New York, Minneapolis, I think Austin. So if you'd like to work with me, just come by, chat. I'll give you a card. And thank you for attending this presentation. After you had a full stomach, here's a picture of my cute dog, Daisy May. Yeah, she's home where I am right now.